Hello friends, welcome back to my channel Math School. Today we will discuss IIT JEE Advanced 2024 Paper 1 Section 1 Question number 2. Now let's go to the question number 2. A student appears for a quiz consisting of only true-false type questions and answers all the questions. Note down, answers all the question. The student knows the answer of some questions and guesses the answers for the remaining question. That means either he know or he guess. Whenever the student knows the answer of a question, he gives the correct answer. That means if he know, then he give correct answer. Probability of giving correct answer is 1 when he knows the answer. Assume that the probability of the student giving the correct answer for a question given that he has guessed it is half. That means probability of correct answer given that guessing the answer is half. Also assume that the probability of the answer for a question being guessed given that the student's answer is correct. That means probability of guessing the answer given that the answer is correct is 1 by 6. Then find the probability that the student knows the answer of a randomly chosen question. And there are 4 options. Only one answer is correct because it is from section 1. So it is clear that the question comes from the topic statistics and probability, and more precisely the topic is Bayes theorem. To solve the question, we need to recall the topic Bayes theorem. So let E1, E2 up to En be the set of events. N can be any number. It can be 1, 2, 3, 4, anything. So let there is n events E1, E2 up to En associated with a sample space S, where all the events, that means E1, E2, all the events have non-zero probability. That means probability of EI is not equals to 0. And they form a partition of S. That means E1, E2 all are mutually disjoint. That is EI intersection EJ is equals to 5 for all I and J. And they are mutually exhaustive also. That means sample space S equals to union of EI where I runs from 1 to N. Now let A be any event associated with the same sample space S. Then Bayes theorem states that probability of EI given A is equals to probability of A given EI into probability of EI by summation of probability of A given EK into probability of EK. K runs from 1 to N. Actually, Bayes theorem is nothing but the combination of definition of conditional probability and the law of total probability, because probability of EI given A means, according to conditional probability definition, it will be probability of EI intersection A by probability of A, and the upper part, that means numerator, probability of EI intersection A can be think as probability of A given EI into probability of EI, and the denominator probability of A can be written as a sum form using the law of total probability. Now let's use this Bayes theorem in the given question. Now since the student answers all the questions and either he knows the question or he guesses the questions, so we can say that probability of guess and the probability of knows the answer are just complementary event. So probability of guesses is equals to 1 minus probability of knows. Now let G indicates guessing the answers, K indicates knowing the answer, and C indicates giving the answer correct. Now, given that probability of C given G, that means probability of giving correct answer given that it has been guessed, is equals to half, and probability of G given C, that means probability of guessing the answer given that the answer is correct, is equals to 1 by 6. And also probability of C given K is equals to 1, because if he know the answer, he gives the correct answer. So probability of C given K is 1. Now let probability of K is X. Then probability of guess is equals to 1 minus probability of nose, implies that probability of G is equals to 1 minus X. Okay, now if we use the Bayes theorem, why should we use the Bayes theorem? Because we need to find probability of K, and we have probability of C given G and probability of G given C, and also probability of C given K. It is clearly visible that K and G are nothing but E1 and E2. That means the events who are mutually exclusive and exhaustive. And C is the event A. So we should use the Bayes theorem here, and by using the Bayes theorem we can write probability of G given C is equals to probability of C given G into probability of G by probability of C given G into probability of G plus probability of C given K into probability of K. Now put all the values. After putting the values, we will get 1 by 6 is equals to 1 by 2 into 1 minus x by, again, 1 by 2 into 1 minus x plus 1 into x, which implies that 1 by 12 into 1 minus x plus x by 6 equals to 1 by 2 into 1 minus x. This implies x by 6 equals to 1 by 2 into 1 minus x minus 1 by 12 into 1 minus x. So x by 6 equals to 5 by 12 into 1 minus x, and if we simplify it after cross multiplication, we will get 2x equals to 5 minus 5x, which implies 7x is equals to 5 and x equals to 5 by 7. So you can see that option number C is correct, 5 by 7. So what we have used here, the Bayes theorem. When conditional probabilities are given, we should use Bayes theorem. In maximum cases, maybe just total law of total probability, or just using conditional probability we can get the answer, but Bayes theorem is the combination of these two, so this type of question comes more. Thanks for watching. We will solve the question number 3 in the next video. Till then, stay tuned, and if you like the video, please don't forget to like, share and subscribe.